Okay. So if you look over here, okay, where they have question about write the ionic equation for the reaction between sodium carbonate and dilute nitric acid. Now, first thing that you need to do is, okay, you need to write down the equation. Okay, sodium carbonate, okay, sodium carbonate. This is sodium carbonate, Na plus and CO3 2 minus sodium carbonate, and then dilute nitric acid, so HNO3. Now, we know that all sodium salts, okay, they are soluble. Therefore, this is aqueous. Okay, take note there. All this IGCSE knowledge, all sodium salts are soluble. All potassium salts are soluble. Okay, and so on. So acid, nitric acid, okay, aqueous. You are going to have, okay, do remember acid plus, okay, acid plus carbonate will always give you, okay, the salt, which is sodium nitrate, plus water and then carbon dioxide. So the next thing that you need to do is to balance the equation. So how do I balance the equation? So you see there's 2 Na, so I put 2 there. NO3, so I need to put 2 there. Hydrogen, there's 2. Okay, oxygen, total 3. I have total 3 over there. And then nitrate is all balanced. Okay, so this one I can actually say that it's already balanced. Okay, now do remember all sodium salts are soluble. All nitrate salts are also soluble. So therefore, this is aqueous. This is liquid. This is going to be gas. Now, when you want to write the ionic equation, take note of this here. Whenever it is in aqueous form, it means that the ions can separate. Okay, they can separate into anions and cations. But when they are in solid form, which is going to be precipitate, we won't be able to separate them into ions. For example, later I'll show you one example like zinc. Okay, they don't actually change into ion, it's just zinc. But what happens if you are talking about a precipitate? For example, silver chloride. Okay, later I'll actually give you some examples on this. So the precipitate, they do not actually change when you add water because they are insoluble. So they don't actually form any kind of ions. Okay, let's actually look over here. If I want to actually write down, okay, the ionic equation, so you see aqueous, so they will actually form 2Na plus CO3 2 minus, aqueous they will separate, plus 2H plus 2NO3. Why they separate? Okay, because it's aqueous. 2Na plus and 2NO3 minus, aqueous, they separate. But how about water? Do they separate, Raphael?
No.
No. Okay, so water will remain as water. Okay, carbon dioxide will remain as carbon dioxide. Okay, so you just need to put H2O and then carbon dioxide. Okay, later of course I will actually write down all the states later, but now I want you to actually take note of the one that is going to be same left and right. Okay, so if you look at the one that is same over here, there's 2Na plus and you have 2Na plus. And okay, let me admit James. Okay, now I also have two NO3 minus, and I have 2NO3 minus. The rest are different. Okay, the rest are different. Now, what does it mean over here? Okay, it's like this. Okay, I'll just put it, I like to use this analogy. Now, in a football game, okay, let's say this is Manchester United, Man U. Okay, Man U is going against, okay, let's say Manchester United going against with Liverpool. Okay, this is going to be Man U with Liverpool. Okay, at the end, there will be reactions. Okay, there will be reactions where these are the results. Okay, whether which one wins or which one lose. Okay, but now if you look over here, the Na. Okay, let's say this Na is their Man U supporters. And then, okay, to give you again after the match, they still there, menu supporters. Okay, and then NO3, let's say they are Liverpool supporters. After the game, okay, you also have the Liverpool supporters over there. Now, so what happens over here when there is a game, okay, and then the Man U and Liverpool they play the game, and then they actually either can who wins, okay, let's say in this situation, Man U won, okay, Man U won, and then they actually give you the product, okay. Let's say this one Man U won, okay, to give you carbon dioxide, so they lost, okay, Liverpool lost. Now, even though the supporters they go in, okay, they actually, of course, okay, the Man U supporters will be extremely happy, okay, extremely happy, but they don't get changed, okay, they are still going to be Man U supporters. They are not actually the one that is actually playing, okay, they will be still there. So the main players over here, okay, the main players over here is going to be only Carbonate, only going to be the Liverpool H plus, and the products will be this. But the remaining, okay, the remaining, once they enter before, let's say this is before, and after, they are the same, as though that they are not actually significant. Okay, they are not significant. So what happens over here is we can actually remove them. Okay, we can remove them. So NA doesn't matter. Okay, doesn't matter. If I can remove, okay, the Liverpool supporters, doesn't matter. Okay, because why? Okay, we call them as, okay, like in a football stadium, when you go and support a team, we call them as spectator. In chemistry, we call it spectator ions. What are spectator ions? They are there in the reaction, but they do not take part in the reaction. So what happens over here is you are going to get, okay, you are going to get an ionic equation, which is going to be 2H plus CO3 2 minus to give you H2O and CO2. And then you can write over here aqueous, okay, and then liquid, you can write gas. This is what we call as ionic equation. So just put it down there. Okay, this is going to be the ionic equation. Now, if I actually try to do the same thing for zinc plus copper sulfate, zinc is solid, okay, copper sulfate is aqueous. So what will happen? Okay, this one in IGCSE, you should know that, okay, more reactive metal will displace the less reactive ions in a solution. So in this case, zinc is more reactive, so they will displace. So it's like a boyfriend, okay, a guy, okay, a very muscular guy or very handsome guy, and then you have one guy not so handsome, okay, another girl. So what happens over here is this girl, okay, the relationship can be broken because of this guy, so they will get together. Why? Because this guy is more reactive, okay, more reactive. So what happens is the one that will end up crying over here is going to be the copper, okay, will be end up crying, will become solo. Yeah, that's very sad. So again, what's going to happen? You are going to get zinc sulfate, okay, and then you are going to get copper, okay, will be displaced. This is solid, okay, and then this one is still aqueous. uh, so what happens if we want to actually write down, okay, the ionic equation for this? Okay, I'll erase this part, not so important. Okay, this is a displacement reaction. Okay, so now if I actually want to write down the ionic equation, what happens is zinc, okay, they do not actually change into ions, okay. Then you have copper aqueous, so they will become copper 2 plus, sulfate 2 minus, zinc sulfate, okay, aqueous, so you are going to have this. And then copper, they just stay as copper, okay. Now the spectator ions, there are two spectator, how many spectator ion here? I can only see one spectator ion, okay. The spectator ion that we are talking about is the sulfate, okay. The rest of them, they are different, zinc to zinc 2 plus, copper 2 plus to copper, okay. In IGCSE you would have actually learned also, okay, the oxidation number, okay, is actually given by the number that you have. Like for example, element oxidation number is 0, okay. If you have ion, the oxidation number will follow the ion, okay. For example, okay, if I want to relate to redox reaction over here, zinc is 0, zinc 2 plus is plus 2, and I can say that from 0 to become zinc 2 plus is going to be increase in oxidation number 0 to plus 2, okay. So this is going to be oxidized, okay. Zinc is going to be oxidized, and I know that from here this is plus 2 and this is going to be 0, okay. And I know that copper 2 plus is going to be reduced over here, okay, because decrease in oxidation number. Okay, why I'm teaching you this later, I'm going to actually show you one trick to balance an equation using this method. Okay, later I'll show you. Okay, but anyway, if you come back over here, okay, this one is going to be, okay, we want to actually identify the spectator ion. The spectator ion that we are talking about is sulfate. But anyway, just now based on the oxidation number, you should know that this is going to be a redox reaction. Okay, it's a redox reaction because it involves reduction and oxidation. But anyway, we cancel this. Okay, these are the spectator ions. So you are going to have zinc plus copper 2 plus to give you zinc 2 plus and then copper. Okay, then this is solid, this is aqueous, this is aqueous, and this is going to be solid. So this is going to be your ionic equation. Is there any question so far?
Sir, may I go to the toilet?
Yeah, can. Now, the next question over here, okay, you have silver nitrate with sodium chloride. Now, this one is called double displacement. Okay, it's called double displacement. Why? Okay, because sodium is more reactive than silver. Okay, it's like two partners exchanging their partners, you know. So let's say here. So what happens? Okay, this is a guy. This is also a guy. So he will actually take this girl. Okay, this girl will take this guy. Okay, so it's a double displacement. Okay, double displacement. So they will end up. Okay, they will end up with this, and then this, this with blue. Okay, so what we are going to get? We are going to get sodium nitrate plus silver chloride. Now, what is important over here is this one is aqueous, silver nitrate, all nitrate salts are soluble. Okay, this one is aqueous, but silver chloride, okay, silver chloride, okay, you should know that they are insoluble. Okay, it's a solid, it's a precipitate. Okay, how do we know that? Okay, you should know by now. Okay, because silver chloride, silver bromide, silver iodide. If previously you do not know, now you know. Okay, they will always form precipitate, and the precipitate color also you need to know. The color of this precipitate is white. Memorize, yeah. The color of this is going to be cream, and the color of this is going to be yellow. Okay, silver chloride, silver bromide, silver iodide. Very important in chemistry. So now, okay, now we need to actually write down the ionic equation. How do I write the ionic equation? So you have Na plus, Cl minus, Ag plus, NO3 minus to give you Na plus, NO3 minus. Okay, this one, silver chloride, you don't change it into Ag plus and Cl minus. Okay, the reason? Because they are insoluble. Okay, so you write down AgCl, that's it. Okay, don't actually separate them. Okay, Then you need to identify the spectator ion. The spectator ion that we are talking about is going to be this one, sodium. Sodium. Okay, we also have, okay, nitrate. Okay, nitrate. Okay, so this one you can cancel. So you are going to actually have, okay, you are going to have Ag plus Cl minus to give you AgCl. This is solid, this is aqueous, this is going to be aqueous. So this is going to be the ionic equation.